In the next couple of lessons, we're going to start looking at transformations of functions. So basically what this means is we're going to be looking at shifts, so sliding a function, as well as reflecting, as well as shrinking and stretching functions. So in this lesson, we're going to focus on translating functions. So translations are basically is when you're moving a function. So it's shifting a function in any direction. So this could mean right, left, up, or down. So the first type is our vertical shifts. Vertical shifts, so if you're given this function and you have a number being added at the end, that means you're going to be shifting upward. So this is going to be up C units. So basically you're going to take one of our parent functions and you're going to see like a +3 at the end. And that just means you're going to take those parent function graphs and you're going to move it up 3 units. If you see the -c, that means you're going to be going down C units. So towards the negative numbers. So if we look at this example here, if I have my parent function, so this is called the parent function because that's the original. So if my parent function is f of x equals x squared, I know that I'm just going to do a rough sketch, but I know that that's a parabola whose vertex is at the center, and I know that both ends should be going up. So this is just a rough sketch, and again, because I don't have like a grid on here, I just have the x and y axes, I'm just doing a rough sketch. Now if I had the actual grid though, I'd have to plot points and be a little bit more accurate. So basically what I'm going to do, if you look at this one, since the +2 is at the end, this means I'm going to be going up 2. So I'm going to take this vertex, which is going to work as one of my key points, and I'm going to move that up 2 units, and that's where my parabola is going to go. So the parabola is going to stay the same shape and size. The only difference is it's going to move up. So these parabolas are actually the same. I'm just shifting it. I know my drawings don't look perfect, but you get the idea. So for this one, we're going down 2 units because the 2 is at the end and it's a -2. So that tells me I take this picture and I shift it down 2 units. So everything's going to stay the same. We're just shifting down 2 units. So all 3 of these parabolas should be matching. So those are vertical shifts. The next type of shifts are horizontal shifts, so meaning left or right. So with horizontal, it's a little bit different than what you would think. Vertical makes sense. If it's positive, it's going up. If it's negative, it's going down. Horizontal, it's the opposite. So one thing too to know is for horizontal, the shift is going to happen inside of the function. So notice how these, the -c and the +c are inside of parentheses, where up here, the +c and -c were on the outside. So vertical shifts happen when you have a number being added or subtracted on the outside of the function or like at the end of the function. And horizontal is when the shift is happening within the function. So it's going to be the opposite of what you think. So -c, you would think we would be going to the left, but it's actually going to be going towards the positive numbers. So this really means right C units. And then this one would be left C units. So remember, horizontal would be right or left, and vertical is up or down. And to kind of help remember what's happening here, so since it's right and left when it's in the inside, and we do the opposite for horizontal, we have this saying, or this acronym that we use for these, and let me just write it up at the top here. We call it HIVO. So basically, HIVO, it's just a way to help us remember when it's horizontal, a horizontal transformation or translation in this case, but it works for all transformations, your shift is going to be in the inside. So this stands for horizontal inside. And you're going to be doing opposite what you think. So this is what you're going to do opposite. So if you are moving towards the negative numbers, you actually add that number to it. And then the vertical part of this, so VO stands for vertical outside. So that means if you're doing a vertical transformation, any kind of vertical shrinking, stretching, reflection, it's always going to happen on the outside of the function, where horizontal always happens within the function, in the parentheses. And vertical is always going to be the same as what you would think. So it's what makes sense. So if you're adding, you're going to be moving up. If you're subtracting, you're moving towards the negative numbers. So that's just an acronym to help us remember the different rules. And it's going to be more helpful when we start seeing other types of transformations. But for right now, we're just focusing on translations, which are just a subcategory of the big picture transformations. So let's look at this bottom example with the horizontal shifts. So we said horizontal, we have right C and left C units. So again, we're going to start with that same quadratic as my parent function. So this is the parent function. And then we're going to do this shift to it. So again, it's horizontal because it's in the inside of the function. And it's -2, so really that means I'm going right 2. So we're going to move right 1, 2. We're going to start our vertex or our key point there. And we're going to sketch the same exact parabola that we just did. And then this last one, it's +2, which really means left 2. And again, you know it's horizontal because it's in the parentheses, it's inside of the function. So when you're thinking about HIVO, it's in the inside, so it's horizontal, and you do the opposite of what you think. So left 2, and sketch the exact same picture, again, doing your best to make them look the same shape and size. So that's really it for the shifts. Understanding the difference between horizontal and vertical, the next thing that you have to be able to do is you have to be able to look and come up with a more accurate equation and a more accurate picture. So if you go to the next page, this example here is going to be a little bit more accurately drawn because I have a grid behind it. So it gives us this piecewise function. So we have, it looks like a linear piece and maybe a quadratic piece. And it tells us this is the domain, -5 to 3. So this means these are endpoints. The function ends there. And we want to sketch the graph given these two shifts here. So this is going to be our graph number 1, and this will be our graph number 2 because we're trying to come up with g of x and h of x. So g of x, basically what it's saying is it took f of x and it added 3 to it. So since it added 3 on the outside, so if we're thinking about HIVO, if we're adding on the outside, that means it's going to be a vertical movement. So the +3, since it's vertical, we do the same as what makes sense, means we're going to take this function and we're going to go up 3 units. Now, because we're on a grid, we have to figure out any key points that's going to make this picture look congruent to its original. So when I'm on just a set of axes on the previous page, I was just doing a rough sketch and it wasn't really drawn to scale. But now I need to do a little bit better of a job of making sure that this transformation actually looks like the original. So what I'm going to do is I'm going to pick out any key point. So basically where my graph changes. So the endpoints are definitely important points, as well as this point right here. And probably I see, like this point might be a good point to shift. Basically, I can get a straight line and then this will help me get that curve. I could probably pick another point just so that I'm making sure I'm getting a pretty accurate curve for that. So what I'm going to do is I'm going to take these points that I just plotted and I'm going to move each of them up 3. So I'm going to go up 1, 2, 3 for each point. And once I do this, once I count up 3 for all of them, I'm going to go ahead and I'm going to connect them. So I'm going to use my line here. And then for the other part, I'm just going to kind of have to sketch it as best I can using my key points. But because we have those key points, our graph is a little bit more accurate. So that would be this graph here. In purple would be the function g of x. So I'm going to just go ahead and label that g of x. Now the next thing I'm going to do is I'm going to do h of x. So h of x, if you look, the minus 4 is in the inside. So when we're looking at HIVO, horizontal is in the inside, so that means it's going to be a horizontal. Because it's minus, that tells me that I'm actually going to be going to the right. So we're going to go right 4. So I'm going to take each of those key points from the original and I'm going to move them right 4. So 1, 2, 3, 4. I'm just going to replot them. So 1, 2, 3, 4. 1, 2, 3, 4. So we're just replotting all of these. And we're going to connect. As best you can, and that's going to be function h of x. So that's it for that piece. So that's on a grid. You just have to pick those key points and shift those points and then redraw your picture so that you can see what happened. The picture just moved up. So the next thing that we're going to look at is, well, what happens if they give us the picture or they give us the graph and we have to come up with the formula this time. So the first thing you always want to do is you want to decide what's the parent function. So the parent function is usually going to be the function that's going through the origin, 0, 0. And it's going to be one of those, it's either going to be a quadratic, it could be the absolute value, it could be just x to the third, just a basic function that doesn't have any numbers involved. So the parent function in this one, I know is going to be this graph right here, this quadratic, and I know that it's a parabola, so I know that its name is going to be, or its equation is going to be f of x equals x squared. And I know that because, again, I know that the general shape of a parabola has an x squared, and because this is the one that starts at 0, 0, and then it has the coordinates 1, 1, 2, 4. These are like your basic points for x squared. If you plug in 0, 1, and 2, you get 0, 1, and 4. So that's kind of how I know that this is the quadratic that I'm looking at. So this one's the parent function, so I'm going to label f of x. So now what you want to do is you want to come up with the formula of the translated graph. So you need to decide, well, how did I get from the parent function to this one? So it looks like if I look at the key points here, it looks like I just shifted 1, 2, 3, 4 units. So since I shifted 4 units right, so let's say that the shift that occurred here was 4 units right. That means when you think about HIVO, this is the horizontal inside situation because we went 4 units to the right. So that means when I write this new equation, it's going to be, let's call it something different. So I'll call it g of x instead of using the same letter. When I write my new equation, it has to be, the shift has to be represented in the inside of the function. So instead of writing x squared, I have to have this quantity squared because my shift has to occur within the function. The function is whatever the input is, you square it. So whatever my input is has to be squared. So it's going to be x, and then instead of plus 4, because we're going to the positive numbers, horizontal, you always do the opposite, so minus 4. So this is going to be my g of x, and my equation is just the quantity x minus 4 squared. So this would be the actual answer to the question. So let's just look at one more. So this one, as soon as I see this picture, I know that my parent function is going to be the absolute value function. So the parent function, or the original, is absolute value because of the v. I know that it's the absolute value, so that's this one. And again, you can look at, okay, well, that's the one that starts at the origin. You also can think about the points of the absolute value. So if you plug in 1, you're going to get out 1. If you plug in 2, you're going to get out 2. If you plug in 3, you get out 3. Same with the negatives. If you get out if you plug in -1, you get out 1. Plug in -2, you get 2, and so on. So I know that that's my parent function. So that really comes down to knowing those parent functions and being able to recognize them. The next thing is we have to decide, well, what did we do to that parent function to, to get to this new one? So the first thing I see is I went, it looks like left 1, 2. So we went left 2. And then down 1, 2, 3. So to go from this point to this point, we went left 2 and then down 3. So I'm going to say left 2 and down 3. So that means there's actually two things that happen. So if we look at our HIVO, or think about the acronym HIVO, for this first shift, I went left 2, so that's going to be an inside, that's a horizontal inside. So that means when I go to write this function, so let's call it g of x again, for this piece left 2, that means inside of the function is where you're going to do this shift, so it's going to be x plus 2. Because remember, we always do the opposite for horizontal. But then for the vertical, so let's say this is my step 2, I went down 2. So that's the vertical shift, which means that has to go on the outside. So that means I'm going to take and I'm going to keep what I have with this absolute value, but then on the outside I have to put this 3. I have to do the down 3, and since horizontal is always opposite and vertical is always the same, down 3 means I'm going to have just a -3 because I'm actually moving down. So that's going to be your g of x. So it doesn't matter if I would have said down 3 then left 2, you would have gotten the same equation in the end, so that part doesn't matter. I just chose to go left 2 and then down 3 first, so I represented this equation represents left 2, where this one represents both things. So g of x would have to have the +2 in the absolute value and the -3 at the end. So that's really it for transformations, or for translations. The next thing we will be looking at are talking about shifts, or talking about shrinking and stretching and reflections.